There is a crack in the Earth hiding under the Pacific Ocean right now. It runs for over 1,000 kilometers along the west coast of North America, from Northern California all the way up to Canada. And right now, at this very moment, that crack is being squeezed by forces so powerful they could level entire cities in a matter of seconds. Scientists call it the Cascadia subduction zone. And here's the scary part. It has already done this before. The last time it went off, it was so violent that it changed coastlines overnight. The ground dropped by 2 meters. Entire forests were drowned. And a wall of ocean water taller than a 3-story building raced across the Pacific and slammed into Japan, over 8,000 kilometers away. Nobody in North America even wrote it down because it happened before anyone in the region kept written records. But today, nearly 13 million people live in its path. Cities like Seattle, Portland, Vancouver, and San Francisco sit right on top of it. And scientists now say we have a 37% chance of a massive earthquake striking within the next 50 years. Not a normal earthquake either. We are talking about a magnitude 9. That is one of the most powerful earthquakes that can possibly happen on this planet. To give you a sense of how strong that is, most earthquakes you hear about on the news are around magnitude 4 or 5. A magnitude 9 is not just a little bigger. The scale works in a way where each whole number up means 10 times more ground shaking and about 31 times more energy released. So a magnitude 9 is not twice as strong as a magnitude 7. It is almost 1,000 times stronger. A quake this size can release the energy of roughly 2 million atomic bombs going off at once. That is 31 billion tons of TNT exploding right under your feet. Only about 5 earthquakes that powerful have ever been recorded in all of human history. The most recent was the 2011 earthquake in Japan that killed over 19,000 people and caused $235 billion in damage. The one before that was the 2004 Indian Ocean earthquake that killed 230,000 people. These are the kind of events that change countries forever. And scientists say America's west coast is next in line. But here is what really keeps researchers up at night. A brand new study from Oregon State University, published in 2025, found something nobody expected. The Cascadia Fault and the San Andreas Fault in California might actually be linked. That means when one goes off, the other could follow within minutes or hours. Not one giant earthquake. 2, back to back, hitting the entire west coast at once. That is a level of disaster the United States has never faced. And it is coming. The only question is when. In this video, we are going to break down exactly what is happening under the ocean floor right now, how scientists figured out this has happened before using dead trees and ancient Japanese records, what the latest 2026 research tells us about the fault literally tearing itself apart beneath our feet, and what it will actually look like when this thing finally goes off. By the end, you will understand why some scientists are calling this the most dangerous natural disaster waiting to happen in North America. And if you find this kind of deep research interesting, this is exactly what we do on this channel. We take complex, important topics and break them down so they actually make sense. If you want to stay in the loop when we drop videos like this, hit that subscribe button and turn on notifications. That way you will not miss the next one, especially because some of these stories are time sensitive and knowing about them early could genuinely matter. All right, let us get into it. Section 1. The monster nobody can see. So what exactly is happening under the ocean off the coast of Oregon, Washington, and British Columbia? Why is this area so dangerous? And why have most people never even heard of it? To understand this, we need to talk about how the Earth actually works beneath our feet. And do not worry, I'm going to keep this simple. The outer shell of our planet is not one solid piece. It is broken up into massive slabs called tectonic plates. Think of them like giant puzzle pieces, some of them the size of entire continents. These plates float on top of a super hot, gooey layer of rock deep underground. And because of heat rising up from the center of the Earth, these plates are always moving, very slowly, just a few centimeters a year, but they never stop. Now, most of the time, you do not notice this movement, but where 2 plates meet is where things get interesting, and sometimes terrifying. If you look at a map of the entire Pacific Ocean, you will notice something wild, almost all the way around it, forming a giant horseshoe shape. There's a ring of volcanoes and earthquake zones. Over 450 volcanoes, thousands of earthquakes every year. Scientists call it the Ring of Fire, and it is the most active danger zone on the planet. About 90% of all earthquakes on Earth happen along this ring. 3 out of every 4 active volcanoes on Earth sit on it. Japan is on the Ring of Fire. So is Indonesia, Chile, Alaska. And right there, tucked along the coast of the Pacific Northwest, sits the Cascadia subduction zone. We got a very recent reminder of just how powerful these zones can be. On July 29, 2025, a massive earthquake hit off the coast of Russia's Kamchatka Peninsula. It measured magnitude 8.8, making it the 6th largest earthquake ever recorded with modern instruments. The ground shook for 4.5 minutes. It triggered tsunami warnings across the entire Pacific. and it happened on a fault zone very similar to Cascadia. That earthquake was a wake-up call for scientists. Because if a fault in Russia can produce something that powerful in 2025, the Cascadia fault can do the same or worse. And it is much, much closer to major cities. Off the coast of the Pacific Northwest, there are two plates pushing against each other. One is called the Juan de Fuca plate. It sits under the ocean floor. The other is the North American plate, which is basically the continent you're standing on if you live anywhere in North America. Here is what is happening. The ocean plate is slowly sliding underneath the continent, about 4 centimeters per year. That does not sound like much, right? It is roughly the speed your fingernails grow. But here's the problem. These two plates are not sliding smoothly. In many places, they are stuck together, locked tight by friction. And when two massive slabs of rock are stuck together while enormous forces keep trying to push them, pressure builds. And builds, and builds, for decades, for centuries, until one day the lock breaks. The plates suddenly lurch past each other, and all that stored up energy is released at once. That is a megathrust earthquake. And the Cascadia subduction zone is one of the biggest ones on the planet. Think of it like bending a stick. You can bend it slowly, and for a while nothing happens. But you keep bending it, the tension builds, and then snap. It breaks violently. That is what happens along this fault line. Only instead of a stick, it is over 1,000 kilometers of rock suddenly snapping free. And instead of a small crack, you get an earthquake so powerful, it can release the energy of roughly 2 million atomic bombs going off at once. Now, some parts of the fault do release small amounts of pressure over time. Scientists call these slow slip events. They are basically tiny, super slow earthquakes that happen so gently you cannot even feel them. They take weeks or months to unfold, not seconds. Special instruments can detect them, but your body never would. For a while, some people hoped these slow slips might be letting off enough steam to prevent the big one, kind of like slowly letting air out of a balloon instead of letting it pop. But the data does not support that. The slow slips only happen along certain parts of the fault. The main locked section, where the plates are stuck tightest, is still building pressure with no release at all. Now, here's something that makes the Cascadia zone extra tricky. Most big fault lines around the world produce small earthquakes all the time, little rumbles here and there that let off some steam. The San Andreas Fault in California does this constantly. It causes more than 10,000 small earthquakes a year. But the Cascadia subduction zone, it is weirdly quiet, almost completely silent. And for a long time, that actually fooled people into thinking it was safe. They figured, hey, no earthquakes, no problem, right? Wrong. That silence is not a sign of safety. It is a sign that the fault is locked, completely stuck, not letting any pressure out at all, which means every single year that passes, more and more energy is being stored up, like a spring being compressed tighter and tighter with no release. A February 2026 study from the University of Washington backed this up. Researchers spent 13 years monitoring ground movements near the fault and found that the plates are not locked equally everywhere. Some spots are stuck tighter than others, and the tighter the lock, the bigger the snap will be when it finally breaks. But here's where the story gets even wilder. In 2021, a research ship set out on a major expedition to basically do an ultrasound of the ocean floor. They used special sound pulses and underwater microphones stretched along a 15-kilometer cable to create images of what the plates look like deep underground. And what they found was stunning. The Juan de Fuca plate is not just sliding under North America. It is actually ripping itself apart, piece by piece. Scientists at Louisiana State University published these findings, and their lead researcher, Brandon Shuck, described it by saying it is like watching a train slowly derail one car at a time. In one spot, a chunk of the plate has dropped down by over 5 kilometers. 5 kilometers. Now, some people heard about this and got excited. They thought maybe the fault is shutting down. Maybe the danger is going away. But scientists quickly said, no, that is not what this means. An April 2026 follow-up study made it clear that the fault is not shutting down. It is just more complicated than anyone thought. And that complexity means the next big earthquake might not behave the way older models predicted. It could be worse in some areas and different in others. So we have a 1,000-kilometer fault line, locked and loaded, with the ocean plate literally cracking apart as it gets forced down, and nearly 13 million people living on top of it. And until about 40 years ago, almost nobody knew any of this, because nobody had figured out that this fault had even produced a major earthquake before. That is, until scientists started listening to dead trees and reading 300-year-old Japanese diaries. Section 2, Dead Trees and a Mystery Wave. For most of the 20th century, the Cascadia subduction zone was basically ignored. Sure, scientists knew it existed, they could see it on maps, but it was so quiet, so uneventful, that nobody treated it like a serious threat. No big earthquakes had been recorded in the area. No dramatic damage, nothing. But there were stories, old stories, passed down through generations by the native people who had lived along the coast for thousands of years. The New Cha Nulth people on Vancouver Island told a story about mountain spirits who invited people to dance around a drum. When someone accidentally kicked the drum, the dancer got something called earthquake foot, and every step they took shook the ground and sent the ocean rushing onto shore. People did not even have time to reach their canoes. This was not just one group telling this story either. A research team led by Ruth Ludwin at the University of Washington brought together anthropologists, geologists, and indigenous scholars to study the oral histories of the coast. They looked at over 40 stories from native communities all along the Pacific coast, from California to Canada, the Yurok, the Tolowa, the Squamish, the Tillamook, the Quileute, all of them. Different languages, different cultures, different locations. But they all described the same kind of event. The earth shaking so hard that people could not stand up. The ocean pulling far away from the shore, further than anyone had ever seen, and then flooding back in with terrifying speed. Rock slides burying whole villages. People running for their lives in the middle of the night with no time to grab anything. These were not made-up stories. They were eyewitness accounts, passed down through generations with remarkable detail and care. And they were all describing the same earthquake and the same tsunami. But as powerful as these stories were, legends alone were not enough for the scientific community. They needed hard physical evidence, something they could measure and date. And they found it in the strangest place, a forest of dead trees standing in the ocean. Along the Oregon coast, there's a place called the Nescoan Ghost Forest. If you ever visit, it will stop you in your tracks. Dozens of ancient red cedar tree stumps stand in the shallow water near the shoreline. Their trunks are gray and cracked, weathered by centuries of wind and salt. At low tide, they emerge from the sand like the bones of a world that drowned. At high tide, the waves lap around them. It is one of the eeriest natural sights in all of North America. For years, scientists figured these trees died slowly as sea levels rose over time, letting salt water creep in and poison their roots. A sad but natural process. Nothing dramatic. Just the ocean slowly winning. Then, in 1987, a geologist named Brian Atwater from the United States Geological Survey changed everything. He published a landmark paper in one of the most important science journals in the world, and what he found turned the entire conversation upside down. Atwater was studying the soil near these coastal ghost forests in Washington state, and what he found did not match the slow sea level rise theory at all. The evidence showed that the ground had dropped suddenly, not over centuries, but in an instant, like someone had yanked a rug out from under the coastline. The land fell by as much as 2 meters, and the ocean came flooding in. Trees that had been perfectly healthy were suddenly standing in salt water. They died fast. And buried in the soil around those trees, Atwater found layers of sand. Not normal soil. Sand. The kind of sand that only gets deposited when a powerful wave, a tsunami, rushes inland and dumps ocean sediment all over the place. So now the picture was forming. The ground dropped suddenly. Then a tsunami hit. This was not slow sea level rise. This was a massive, violent earthquake, but one crucial question remained. When? This is where the detective work gets really cool. Atwater teamed up with a scientist named David Yamaguchi, who was an expert in something called tree ring dating. The idea is simple but brilliant. Every year, a tree grows a new ring in its trunk. You have probably seen them if you have ever looked at a tree stump. Those circles going outward are years. In a good year with plenty of rain and sunshine, the ring is wide because the tree grew a lot. In a tough year with drought or cold, the ring is narrow because the tree barely grew. This pattern creates a unique fingerprint for every stretch of time, like a barcode written in wood. By comparing the ring patterns of the dead stumps in the ghost forests to living trees just meters away, Yamaguchi could match up the years. He worked backwards, ring by ring, year by year, like matching puzzle pieces, and he found something very clear. The last ring in the dead trees was from 1699. After the growing season of 1699, the trees simply stopped. No 1700 ring, no 1701, nothing. Whatever killed them happened that winter, between the fall of 1699 and early 1700. They were getting close to an answer, but sometime that winter was not good enough. Scientists needed an exact date if they wanted to understand the pattern and predict the future. And believe it or not, the final clue was not found anywhere in North America. It was found over 8,000 kilometers away, on the other side of the Pacific Ocean, in Japan. Japan sits in one of the most earthquake-heavy regions on Earth. The country gets hit by around 1,500 earthquakes every year. And because of this long and painful history, the Japanese have been keeping detailed records of earthquakes and tsunamis for centuries. Not just vague descriptions either. Written records with dates, times, wave heights, and damage reports, kept by coastal villagers who understood that recording this information could save future lives. In the mid-1990s, a Japanese scientist named Kenji Satake was going through hundreds of these old records when he stumbled onto something that did not make sense. The The documents described a destructive tsunami that hit the eastern coast of Japan in the year 1700. Homes were swept away, fires broke out, over 1,000 bodies were washed ashore. Survivors fled to higher ground in the middle of the night. But here is the truly strange part. There was no earthquake. Nobody felt the ground shake. Not a single person reported any rumbling at all. The wave just appeared out of the darkness, seemingly out of nowhere. 2 meters of raging ocean water smashing into the coast, and nobody knew why. Because of this, scientists gave it a name that tells you everything you need to know. They called it an orphan tsunami, a tsunami with no parent earthquake, no known source, a mystery wave that nobody could explain for nearly 300 years, until Kenji Satake decided to solve it. Using computer models and the old Japanese records, Satake worked backwards. He fed the wave sizes, the timing, the locations into his calculations and asked one question. Where on earth could an earthquake have happened that would send a tsunami of exactly this size to exactly these spots on the Japanese coast, arriving at exactly the times the old records described? He ran the numbers, and the math pointed to one place, the Cascadia subduction zone, over 8,000 kilometers away across the Pacific. The earthquake would have needed to be a magnitude 9 to produce waves that big at that distance. Huge sections of the ocean floor would have been shoved upwards, pushing an enormous volume of water in all directions. Waves up to 5 meters high would have raced across the Pacific toward Japan at hundreds of kilometers per hour, arriving at the coast roughly 10 hours later in the middle of the night, which is exactly what the old records described. By combining the computer models with the tree ring data from Oregon, the sediment layers from the coast, and the Japanese written records, scientists were finally able to pinpoint the exact date and time. On the night of January 26, 1700, at around 9 p.m. local time, a silent and massive rupture beneath the ocean unleashed one of the most powerful earthquakes the west coast of North America has ever seen. The ground shook for several minutes, the coastline dropped by 2 meters, entire forests were drowned in salt water in a single night, and a tsunami raced across the Pacific Ocean, devastating communities in both North America and Japan. The native stories that had been passed down for hundreds of years were real. The ghost forests standing dead in the surf were evidence, and the orphan tsunami that had puzzled Japanese scientists for centuries finally had a parent. It was one of the greatest geological detective stories ever told, and it revealed something deeply unsettling. The last time this happened was over 326 years ago, and ever since that night in January 1700, the pressure has been building again. Slowly, quietly, without pause. The next question is obvious. How much time do we have left? Section 3. 2 faults, 1 nightmare. To figure out when the next one might hit, scientists needed to go further back, way further. Not just to 1700, but thousands of years into the past. They needed to know how often these earthquakes happen and whether there is any kind of pattern. A marine geologist named Chris Goldfinger at Oregon State University spent years doing exactly this. His team went out on research ships and drilled into the deep ocean floor along the coast. They pulled up long tubes of sediment, basically cylinders of mud and sand stretching back thousands of years. Think of each tube like a timeline buried under the ocean. The deeper you go, the further back in time you travel. In normal years, the ocean floor collects thin layers of fine, soft mud. Nothing exciting. But when a massive earthquake hits, it triggers underwater landslides. Huge amounts of sand and gravel come tumbling down and land on top of that soft mud, creating a thick, coarse layer that stands out like a bookmark in a book. By finding these thick layers, counting them, and dating them using carbon testing, Goldfinger's team was able to count how many major earthquakes had happened over thousands of years, and roughly when each one occurred. It was painstaking work. Each core took careful analysis, but the results were alarming. Over the past 10,000 years, the Cascadia zone has produced between 41 and 43 major earthquakes of magnitude 8.2 or higher. That works out to roughly 1 every 200 to 500 years. Some hit the entire fault from California to Canada. Others only broke part of it. Now, here's where the math starts to get uncomfortable. The last full rupture was in January 1700. That was 326 years ago. And looking at the historical record, we have already gone longer without a major earthquake than 75% of the gaps between past events. Within 50 years, that number is expected to rise to 85%. In other words, by historical standards, we are overdue. And each year that passes without an earthquake just means more pressure is building up for the next one. Current estimates from scientists and emergency agencies give us a 37% chance of a magnitude 7.1 or larger earthquake in the next 50 years. For the northern section of the fault, from coastal Oregon up to British Columbia, there is a 10 to 15% chance of a full magnitude 9 or above event. Those numbers might not sound huge, but think about it this way. If someone told you there was a 37% chance your house would catch fire in the next 50 years, you would buy a fire extinguisher today. But the story gets worse, much worse. Remember Chris Goldfinger? The same scientist studying the ocean floor sediments? Well, something unexpected happened during one of his research trips back in 1999. His team was collecting sediment samples off the coast of Oregon to study Cascadia earthquakes. But during the night, a mistake happened. A crew member entered the wrong coordinates. When the team woke up, they realized the ship had drifted about 90 kilometers south of where it was supposed to be. They were no longer in Cascadia territory. They had accidentally drifted into the zone controlled by the San Andreas Fault. Now, most scientists would have just corrected course and moved on, but Goldfinger figured, hey, we're already here, might as well grab some samples. And that accidental detour changed everything. When the team later analyzed those samples, they found something chilling. The sediment layers near the San Andreas looked almost identical to the ones from Cascadia. Same structure, same thickness, same timing. It was as if both fault systems had been going off at the same time. Goldfinger's team spent years investigating this further. They published their results in 2025, and the findings shook the scientific community. The data showed that at least 10 times over the past 3,100 years, the Cascadia subduction zone and the northern San Andreas Fault ruptured within hours or even minutes of each other, including the most recent event in 1700. Let that sink in for a second. The two most dangerous fault lines on the entire west coast of North America appear to be connected. When one goes off, the other may follow almost immediately. Goldfinger himself summed it up perfectly. He said that everyone has been talking about the big one as if it is one giant earthquake. But the real worst-case scenario is not one quake. It is two. A Cascadia megathrust followed almost instantly by a San Andreas rupture, or the other way around. Think about what that means in real terms. Seattle gets hit by a magnitude 9. While rescue teams are scrambling, while buildings are still falling, while people are still trapped under rubble, California gets rocked by a massive San Andreas earthquake at the same time, or within hours. Portland, San Francisco, Vancouver, all at once. Emergency rooms flooded, airports destroyed, highways broken, phone networks down across the entire coast from Canada to Southern California. As Goldfinger explained, normally when a big earthquake hits one region, the rest of the country sends help. Fire trucks, ambulances, military support, all of it flows in from other states. But if the entire West Coast is affected at the same time, there is nobody left to send. Every city would be on its own. Now pair that with what we just learned about the plate tearing apart underground. New research in 2026 showed that the Juan de Fuca plate is not just sinking, it is fracturing into pieces as it goes down. That means we cannot predict exactly how the next earthquake will behave. It might not rupture the whole fault at once. It could break in segments, or it could go all at once and be even more violent than expected. Scientists are watching this in real time. They have underwater sensors, seismic monitors, and satellite tracking systems all pointed at this fault. The University of Washington received $10.6 million in 2023 to build an underwater observatory right on top of the Cascadia zone to watch for the earliest possible warning signs. But even with all that technology, nobody can tell you exactly when it will happen. What they can tell you is what it will look like when it does. And that picture is terrifying. Section 4. When the ground turns to liquid. When the Cascadia fault finally breaks, here is what scientists expect to happen based on computer models and comparisons to similar earthquakes around the world. First, the shaking starts, and it does not stop quickly. This is not like a small earthquake that rattles your windows for a few seconds and then goes away. Computer models predict the ground will shake violently for somewhere between 3 and 6 minutes. That might not sound long, but try holding your breath for 3 minutes, and you will get a sense of how long that really is. Now imagine your entire house shaking that whole time. The shock waves will blast outward from the breakpoint at nearly 5 kilometers per second. Buildings will start to crumble. Highways will twist and buckle. Bridges that took years to build will collapse in seconds. Power lines will snap. Water mains will burst. Gas pipes will crack open. By the time the shaking stops, an estimated 1 million buildings could be damaged or destroyed. Every phone line, every cell tower, every power grid along the coast could be knocked out. Millions of people will be left in the dark with no way to call for help. But the shaking is just the beginning. In certain areas, especially around Seattle and Portland, the ground itself will do something almost impossible to believe. It will turn into liquid. This is called liquefaction, and it happens when earthquake vibrations shake the water trapped between grains of soil. Normally, those grains lock together and hold everything up, but when the shaking is strong enough and lasts long enough, the water pressure pushes the grains apart. The ground loses all its strength. Solid land starts behaving like thick soup. When this happens, buildings do not fall over sideways. They sink straight down into the ground, sometimes by several meters. Roads buckle and ripple like waves frozen in concrete. Cars get swallowed into the ground as if the earth just opened its mouth. If you have ever seen videos of liquefaction from past earthquakes in Japan or New Zealand, you know how bizarre it looks. Solid ground just stops being solid. Water and sand bubble up through cracks in the surface. Entire parking lots tilt at angles like something out of a disaster movie, except it is completely real. About 15% of Seattle sits on soil that is vulnerable to this. Portland's industrial district, which has miles and miles of gas and oil pipelines running underneath it, is one of the highest risk areas. If those pipelines crack open during liquefaction, and a single spark ignites the gas, the result would be catastrophic. We are talking about fires on top of earthquakes, on top of collapsing buildings. And if all of that was not enough, the worst part might still be coming. Because if the earthquake happens under the ocean, which is exactly where the Cascadia fault sits, a tsunami follows. When the ocean floor suddenly lurches upward during a megathrust earthquake, it pushes an enormous volume of water out of the way. Billions of tons of ocean water get displaced in an instant. That water has to go somewhere, and it does, in every direction, fast. Computer models predict tsunami waves along the Oregon coast could reach 24 to 30 meters high. That is roughly the height of a 10-story building. And these waves do not work like normal ocean waves that crash and pull back. These are what scientists call shallow water waves. Their wavelength can stretch over 500 kilometers. That means the wave does not just hit and leave. The water surges inland and keeps coming, for minutes. Then another wave arrives, and another. The gap between waves can be up to 2 hours. These waves would travel at around 800 kilometers per hour. That is roughly the speed of a commercial airplane. Coastal towns could have as little as 10 minutes warning before the first wave hits. In some low-lying areas, it could be even less, maybe 60 seconds. And the flooding would not stay local. The tsunami would cross the Pacific and cause damage as far away as Hawaii and Japan, just like it did in 1700. According to estimates from the Federal Emergency Management Agency, a full Cascadia event could kill nearly 13,000 people, with about 70% of those deaths caused by the tsunami. Another 27,000 people would be injured. Over 1 million people would be left without homes. And the immediate cost could top $150 billion. These numbers are hard to wrap your head around. So let me put it another way. The 2011 earthquake and tsunami in Japan cost $235 billion and killed over 19,000 people. 92% of those deaths were from drowning. The tsunami wave there reached 38 meters high in some spots and pushed 10 kilometers inland. It damaged the Fukushima nuclear power plant, which melted down and released radioactive material into the environment. That single event was so powerful, it actually shortened the length of every day on Earth by 1.8 microseconds. The planet literally spun faster because of how much the ground moved. And here's the thing. Japan is one of the most earthquake-prepared nations on Earth. They have built over 400 kilometers of seawalls along their coast, some rising 15 meters high. They have massive underground flood tunnels beneath their cities. They have one of the fastest early warning networks ever built, capable of sending alerts to every phone in the country within minutes of a quake being detected. They run earthquake drills every single year. Children grow up practicing what to do from the time they are in kindergarten. The entire culture is built around knowing that earthquakes are coming and being ready for them. And it still killed 19,000 people. The damage was still $235 billion. The recovery took years. Now compare that to the Pacific Northwest. There are no seawalls protecting the Oregon coast. There are no massive underground flood tunnels in Seattle. Warning systems exist, but are more limited. Many residents have never even heard of the Cascadia subduction zone. Some who have heard of it shrug it off because it has never happened in their lifetime. The gap between the size of the threat and the level of preparation is staggering. And that brings us to the most important question. What is actually being done about it? The honest answer is some things, but not nearly enough. The most dramatic example of preparation so far comes from a small community in Washington state. In 2022, the Shoalwater Bay Indian tribe built the first ever freestanding tsunami escape tower in the United States. It sits in Tokeland, Washington, and it stands 15 meters tall. It can hold over 400 people. It is anchored deep into the ground with concrete supports that go down 16 meters, and it is engineered to survive the kind of shaking that only comes once every 2,500 years. For the people of Tokeland, who live on a flat peninsula with no high ground within running distance, this tower is a lifeline. When the shaking starts and a tsunami could be just minutes away, they have somewhere to go, somewhere that is built to survive what is coming. The tribe named it the Auntie Lee Tower in honor of their retired emergency manager, who spent years pushing for it to be built. She understood that for a community this close to the ocean with nowhere to run, the only option was to go up. But here's the reality check. According to computer models, more than 50 towers like this are needed just along the Washington and Oregon coasts. Right now, there are only a handful, an evacuation shelter above a school gym in Westport, the Tokeland Tower, and a few more in various stages of planning. Some experts say that 50 is not even enough. Japan, for comparison, has built over 400 kilometers of seawalls along its coast. Some of them rise as high as 15 meters. They have warning systems that can alert the entire country within minutes of an earthquake. They run nationwide earthquake drills. Children grow up learning exactly what to do when the ground starts shaking. In the Pacific Northwest, warning systems exist but are more limited. Public awareness is uneven. Some people living right in the danger zone have never heard of the Cascadia subduction zone. Some have heard of it but do not take it seriously because it has never happened in their lifetime. That is the most dangerous part of this whole story. Human memory is short. If something has not happened to you personally, it is easy to believe it never will. But the Earth does not care about what we remember. It operates on its own clock. And the geological record is very clear. This has happened before, many times, and it will happen again. Emergency officials in Oregon are now urging residents to prepare a 2-week emergency plan. Not 2 days, not a weekend. 2 full weeks. Because after a full Cascadia event, communities along the coast could be completely cut off from the rest of the country for that long. Think about what that means. The roads connecting coastal towns to the rest of the state will be destroyed by landslides and broken bridges. Airports will be out. Supply chains will be broken. There will be no grocery deliveries, no fuel trucks, no ambulances coming from out of the area. Cell towers will be down. You will not be able to call 911. You will not be able to text your family in another state to tell them you are alive. For 2 weeks, you are on your own. The state of Oregon officially describes it this way. After a major Cascadia earthquake, coastal communities will become isolated islands, cut off from everything by landslides, cracked roads, and collapsed infrastructure. There will be no outside help coming for days, possibly weeks. Officials recommend knowing your evacuation route before you ever need it. Not just sort of knowing it, but actually walking it. Knowing how long it takes, knowing where the high ground is. They recommend signing up for local emergency alerts, storing enough water, food, and medical supplies for at least 2 weeks, having a battery-powered radio, keeping cash on hand since electronic payments will not work, and having a clear plan for how your family meets up if you are separated when it hits. Some residents are already doing this. Some communities are holding practice drills and teaching children what to do. But when you compare the scale of the threat to the scale of the preparation, the gap is enormous. Most people have not done any of this. Scientists today are watching the Cascadia fault breathe and shift in real time. Underwater observatories are being built to sit right on top of the fault zone, listening for the earliest possible signals that something is about to change. The University of Washington received $10.6 million to build one of these observatories, and it will give researchers a front row seat to whatever happens next. Satellite systems track even the tiniest ground movements, measuring changes of just a few millimeters per year. Seismic sensors scattered across the region pick up vibrations too small for any human to feel, but that might tell scientists the fault is getting ready to move. It is the most watched piece of ocean floor on the planet, and we know more about this fault than we ever have before. We know it has produced magnitude 9 earthquakes in the past. We know the plates are locked and the pressure is building. We know the ocean plate is cracking apart as it sinks. We know the San Andreas might go off at the same time. We know approximately how often these events happen. The one thing we still cannot do is say exactly when. But what every single scientist studying this agrees on is this. One day it will happen, the lock will break, the plates will snap free, the ocean floor will rise, the coast will shake, and the Pacific Ocean will come surging inland once more. The native peoples of the coast knew this. They told their children. They passed it down. They remembered. And for 326 years, the Earth has been quietly proving them right, building pressure inch by inch, year by year, getting ready. The ghost forests still stand along the Oregon coast. The dead cedar stumps poke out of the sand at low tide, silent reminders of the last time this happened. They are not ancient ruins from some distant past. They are a warning. This is what happens here, and it will happen again. Whether that is next year, or 50 years from now, or 200 years from now, nobody can say. But the clock is ticking. And every year of silence from that fault line does not mean it is safe. It means it is getting closer. Because every quiet year is another year of pressure building, another year of locked plates being squeezed, another year making the next release that much more powerful. The final chapter of America's Monster Megaquake has not been written yet, but somewhere deep beneath the ocean floor, it has already begun. The only question that really matters is not if, it is, are we ready? And right now, for millions of people living along that coast, the honest answer is no. That is it for this one. If you found this eye-opening, please hit that like button and subscribe if you have not already. We put a lot of research into videos like this, and your support makes a real difference. Now here is what I want to know from you. If scientists announced tomorrow that a Cascadia megaquake was likely within the next 5 years, would you move? Or would you stay and prepare? I am genuinely curious what you would do. Drop your answer in the comments. I read them. I will see you in the next one.